Bismillahirrahmanirrahim. Welcome to PMDC Online Lecture Room. I am Shah Faisal. Today we will discuss about a buffer solution. A buffer solution is a solution which resists change in pH when a small amount of strong acid or strong base is added to it. For example, human blood is a buffer solution which pH is equal to 7.4. Preparation of buffer solution. There are two types of buffer solution. Number first, acidic buffer. Number second, basic buffer. Buffer solutions are mostly prepared by mixing number first a weak acid and a salt of with strong base. Such buffer are called acidic buffer whose pH is less than 7. For example, a weak acid is acetic acid and its salt of a strong base is sodium acetate. A weak base and salt of with strong acid, such buffer are called basic buffer with a pH more than 7. For example, ammonium hydroxide and its salt ammonium chloride. Buffer action. The resistance offered by a buffer solution to change in pH on the addition of acid or base is called a buffer action. Now we are going to discuss the type of buffer and its buffer action in detail. So number first, weak acid and its salt buffer. A simple buffer solution can be prepared by adding a comparable amount of acetic acid and sodium acetate to water. A solution containing the two substances has ability to neutralize the added acid or base. The pH of the buffer is governed by the equilibrium. So, the acetic acid will ionize partially to acetate ion and hydrogen ion, while the sodium acetate, a strong electrolyte, dissociate completely in water and to its acetate and sodium ions. Now by addition of strong base, when a small amount of strong base like sodium hydroxide is added, it will increase the concentration of hydroxide ion. The excess of hydroxide ion combined with the hydrogen ion of acetic acid to form water molecules. As a result, the equilibrium shifts to the right to produce more hydrogen ion till the excess hydroxide ions are neutralized and the original pH of the buffer is restored. More acetic acid is ionized to recover the deficiency of hydrogen ions. Therefore, the pH of buffer solution will not change and remain a constant. So by adding a strong base, the hydroxide ion combined with hydrogen ion to form water, so the acetic acid will decompose and restore their pH by producing hydrogen ion. Addition of strong acid. When a strong acid is added, Hydrogen ion of acid react with acetate ion of the buffer. Both of these reactions go to completion. Hence, the added hydroxide and hydrogen ions are removed and the pH of the buffer solution remain constant. Second type of buffer solution, weak base and its salt buffer. The example of this buffer is ammonium chloride and ammonium hydroxide. Its resistance to change and pH can also be explained on the same lines as that for an acid buffer. Now by adding a strong acid, when a small amount of strong acid like HCl is added to the buffer, the hydrogen ions combine with hydroxide ions of ammonium hydroxide to form water molecules. The equilibrium is shifted to right till the additional of hydrogen ion are neutralized and the original buffer pH is restored. Addition of strong base. When a small amount of strong base such as sodium hydroxide is added to a buffer solution, the concentration of hydroxide ion increases. The hydroxide ion combines with the excess of ammonium ion to form ammonium hydroxide. Thus, the pH of the buffer remain constant. So, by adding a acid, the acid proton of the acid combining with hydroxide ion forming water. So, more ammonium hydroxide dissociate to restore the pH of solution by producing the hydroxide ion. Application of buffer solution. Number first, the use of buffer is important and some industrial processes which would be interrupted by a large change in pH. Examples are manufacture of the leather, photographic materials and dyes. Number second, in bacteriological research, culture media are generally buffered to maintain a constant pH required for the growth of bacteria being studied. Number third, buffer is important in biological systems because biological reactions in both plants and animals are often very sensitive to pH changes. Human blood is buffered to a pH of 7.4 by means of bicarbonates, phosphates, and complex protein systems. Assignment. Define buffers and its types. How will prepare acidic buffer? Thank you.